Hello, and welcome to Measures of Central Tendency. My name's Tuesday Johnson. Here's an introduction to concept with applications. Let's start with a definition. A stat or a statistic is a fact or piece of data from a study of a large quantity of numerical data. A population is an entire group to be studied, like all the students at UTEP. While it might be really difficult to get some data about every student at UTEP, we might be able to get data about a sample, right? A sample is just a subset of the population. So here's a group of students that we could ask, and maybe they represent whatever we're trying to measure for the entire campus. All right, but this word sample, it gets weird. All right, we use sample a lot. The sample is also a sequence of values of the random variable x. We call sampling the accumulation of such data also. So sample, it all kind of goes together. It's just telling us it's not everybody, but it's a pretty good grasp of, a pretty good representation of people. Now the sample mean is the average of the values or scores in the sample, right? A mean in general. To compute the sample mean, we use x bar, that's a notation for the mean, average. We add up all of our values and divide by n. N is the size of the sample, and the xi are individual scores, and this is all it is, right? x1 plus x2 plus, just add them up and divide by n, just like you're finding your average of 3 exams in a math class. But we can, mathy it up here and make it look hard, even though it's not. This is a Greek sigma. It's a summation. We're going to sum from the I values 1 to n all of the x sub I values. So this is our notation for add them all up, and then we divide by n, the number in the sample size is really what it is. All right, so let's look at an example. Oceanographers are studying the effects of rising ocean temperatures on the lengths of great white sharks. They measure the lengths of several of the species with the following results measured in feet. The mean of this sample, all right, so what's the average shark length? X bar will be, we'll add them up, 18.7 plus 12.3 plus 16.4 all the way out to our last one, 16.2. And our n value, how many are there? There are 8 stats here, pieces of data, datum. Oh boy, math, not English. I shouldn't have went down that road. Let's go back to the intersection, come back here. We add them all up, we get 118.4. We divide by 8, and the average length of a shark in this sample is 14.8 feet. All right. Well, let's talk about some more words here. The mean, x bar, is an attempt to describe where the center of the sample is. So it's called a measure of central tendency, hence the name of this video. Other measures of central tendency include the median. The median is the middle score in an ascending list of values. All right, you could have descending instead. Just order your lists. Either they increase or they all decrease, whatever you want. Find the middle value, literally the exact middle value. For a data set with odd number of entries, it's just the middle one. It's the mean of the middle values for a data set with an even number of entries. The mode is the most frequent value listed. All right, most frequent value listed. There can be multiple modes, but there's only one median and there's only one mean. All right, so in this example, ages of residents of my house. Find the mean, median, and mode for the data. I'm the 50. I'm proud of that, so I tell people. The data is 17, 22, 22, 42, and 50. If I want to find the mean, I will add the 5 values and then divide by 5. 153 divided by 5 is 30.6. The median, remember the median is the middle value. Jumped the gun here. What's in the middle? They're in order already, right? Ascending. There's 5 values, so 1, 2, 3. Middle value is 22. All right, middle value is 22 when they're listed, and the mode, which one happens most? It happens to be 22 because it's listed twice. Daughter and boyfriend are the same age. Yeah, nice when it works out like that. All right, so our middle value here. Seems like that was a little late in the game, but we'll take it, you know. As long as you're learning, late to the game's all right. Let's go back to these sharks, right? We already found the mean of the length of a shark of this data. So let's find the median and mode. If we sort the data into an ascending list, we'll have 5.8, 12.3, 13.2, all the 16s in order, then 18.7 and 19.7. Now we can see that we have, if we have 8 bits of data, 1, 2, 3, these two here are in the middle. The median will add up those two values, 16.2 plus 16.4, divide it by 2, and of course halfway between those two are 16.3. So the mean, which I don't have 14.8, I believe. The mean, 14.8, was not a value that happens to be in the table. And because we have an even number in our sample, our median is not necessarily a number in the data either. All right, so that is possible. Usually the median is a number in the data, but that's only for an odd number of data sets. Otherwise, it's just an average, so it might not be. The mode, the number that is listed most often, there isn't one for this one. There's no repeated values at all, so I would say there is no mode. If we were looking at just the last decimal place, so you have 0.7 and 0.7, we have 0.2 and 0.2, I would say that there are 2 modes in the tenths place, because 7 occurs twice and 2 occurs twice. So you could have multiple modes, or no mode, or one mode, and it's always a value that's in your data set. Median may not be, and mean actually rarely is one of the data points. That's all for this video. I really thank you for watching, listening, and joining me on this adventure. Don't forget to subscribe.